So we will move to the last presentation of today, and I will ask Anna Siekierka from Wrocław University of Science and Technology to tell us about the methods of lithium extraction.
Thank you. Okay. Thank you for the opportunity. I know this is the last time I have the chance to propose. Just briefly summary of my research about the lithium recovery from the not only geothermal water, but general from the sources. We can just find where we can find the lithium cations. I have two strategies for brines and for secondary sources from the lithium-ion battery, lithium polymer batteries. For the brines, geothermal water, I apply the hybrid capacitive deionization. However, for the battery sources, I apply the electrodialysis. This is completely different processes, but they connect by the electromembrane technology, and this is all. For the brines, just focus on the releasing, maybe not adsorption, selectively adsorption, but releasing the lithium from the multi-component mixture. I apply the hybrid system by connection, the typically membrane capacitive deionization, CDI, and battery desalination. Just combine it and obtain the hybrid capacitive deionization, where we have the selective cathode dedicated for the capture the lithium, and combine anode made by the typically porous electrode covered by the ion exchange membrane. For releasing lithium from the lithium, cobalt, and nickel mixture, I apply the electrodialysis, where we can find also two different strategies, or focus on the directly releasing the lithium from the mixture, or just focusing on the transition metal ions, or cobalt or nickel, just separate them from the lithium. The first process I apply for during my research the real sample from the Western Carpathian region, from the Rabka, Krakus, and Barzelnia intake, where we can find the lithium concentration about 50 milligrams per liter and TDS about 20 grams per liter. The typically CDI process completely not work for releasing lithium, but adding the next desorption step, it's moved really well. So please see, with the first step, where we have the selective cathode and combine anode, I just perform the adsorption step, just to absorb the ion into the volume of the cathode and the anode. Then double step of desorption. Why? Because the TDS was pretty high for this method. The accumulation and polarization on the top, on the layer in the both electrodes are visible. So in the first step, I just releasing the solution without lithium, and in the next step of desorption, I release only lithium and a couple of ions. Please see, this is the real sample, where we can find the extraction rate about between 10 and 50% for standard for standard monovalent elements like sodium and potassium, and higher, almost double, for lithium. For typically electronic modes, the process also doesn't work. So we should apply the current in the initial step, then completely release down the potential and reverse the potential. That way we can find the lithium in the second step of the sorting. Please see here, only lithium was released, of course, in some touch of the other cations, but it's just promising step, we can find lithium in this stream. Here we can find the comparison, my research here for other, which we can find in literature. This is extremely fast process because all those paths take only 8 minutes. So it was really big. This is the research for different material in terms of the sorbent. Previously was based on the lithium, manganese, and titanium. Here I just switch the titanium to the iron spinels, and also observe the same behavior. We can find the high selectively lithium in the second step of the sorption without almost any other ions. Also, you can see here over almost 75% of sorbed lithium was released in the second step of the sorption. The next strategy. So we switch from brines to the secondary sources came from the hydrometallurgy nexus. So we have lithium, cobalt, and nickel. To play with this, it's not so easy because we should focus on the transportation across the membrane the lithium, or selected the transition metal ions. However, the separation those metals, cations, by commercial membranes, maybe it's more difficult. So please see what's happening. Or we can apply the commercial, totally unavailable commercially membrane, which focus on the size of the cations. But the lithium and cobalt in some aqueous solution expose only the same ionic radius. So play with the size, it could be tricky. Or we develop different system, which we just focus on the capture, selectively capture the cation, for example, cobalt or nickel. To do this, I just modified the polyacrylonitrile by the hydrolyzation step to occur the carboxylic group. Then substitute this carboxylic group by the chelating agent dedicated for the cobalt recovery, and apply inside the ED process. In one compartment I have feed, in second compartment I have just low concentrated acid permeate, and try to push, transport only selected cation. This is how it looks like, the membranes. It's very stable, a stable membrane without any holes defects, so it's fine. The properties strongly depends of the cations where we just touch to the membrane. But what's going on during the process? I just checked, obviously, time, voltage, and TDS of the initial concentration of all elements. So during the time, we can find the cut-off time, let's say, when we can find the point where the selectivity, the selective factor depend on the cobalt and lithium, just drop down. And this is about 200 minutes. Here we can find the stable transportation cobalt from the feed to the permeate. In the next batch of the research, I just checked the voltage, external voltage of the ED cell. And also, please see what's happened. In higher voltage, the separation factor dramatically dropped down. So it's mean in lower value of the voltage, this process is really stable and really selective for the transportation only cobalt. And the most promising, the selective factor cobalt to the lithium, it's completely resistant for the changing the initial concentration of the both on the all cations inside indefinite compartment. So just to briefly summary, I just apply the hybrid CDI for dedicated for the lithium releasing from the geothermal water and electrolysis for the transportation, selective transportation cobalt from the also multi-component mixture. Thank you very much for your attention.
Thank you so much. I think we have time for one question.
What is the long-term stability of your electrodes? Like, how many cycles can you use them?
By application, the real sample over 100. And this is tricky because it's manganese, it could be lost during the processes, but I just measured it informed by XRD analysis and lost over 6% of the manganese. The initial over 100.
And do you know how the destruction mechanism of the electrodes work? Do you know how it gets destroyed or not?
The manganese spinel just make the disproportion of the manganese. So we have 9 states, valence states of the manganese, and it could be happen that this manganese reach this state, which is dissolved in the water. So it could be tricky that you just lost your solvent during the work working the CDI.
Any more questions?
In the first case that you explained, what is the difference between in the solute between the first desorption stage and the second desorption stage?
Which kind?
On the first setup that you spoke about. I think it's gone.
But you mean the elements in the first step?
Yeah, well, so you're speaking about desorbing some ions and then selectively desorbing. So you're selectively desorbing the lithium in the second stage. So what is the difference in the solution that you're using?
The solution, the composition was the same. However, the differences was in the electrical mode. This is the charge voltage, zero charge, reverse charge voltage. So by application different modes, what does this mean? Or you have stable voltage, or you can have stable current. This is huge differences with the pushing, with the external forces just moving. Try to move the cations from the one side to another side.
But so it's just the deionized water that you're using?
No. Even you can find easily in this paper, because all this data is published. You can find 3 voltage, 4 voltage, 5 voltage. How it's played, because we know that the water just damage in the 1.2 voltage. However, if you have pure water between the electrodes, this is completely not pure process. So we totally resistant to this behavior.
Okay, maybe the last one.
I've read also that during the intercalation and the releasing of the lithium, the structure of the manganese expands and shrinks, and that maybe because of that there is also a loss of material in the electrode, what makes also a loss of capacity. So during the preparation of the electrodes, what is the binding material that you used?
This is the stable electrodes, just mixed by the polymer. That's PVC. You apply 10% of the PVC and build casting the electrodes. It's extremely thin. It's 70 micrometers. So the expansion based on the different size of the cations, it could be neglected. So, fine.
So, thank you for the presentation. Thank you to all presenters. Yes.